All right, this is our Chapter 11 review. So we're going to start off with our measures of central tendency and our ranges of dispersion. So our first question says, home electricity consumption in kilowatt hours over a 12-month period are below. We're going to find our mean, median, mode, range, and standard deviation. So starting off, we have to find the mean. And all we're going to do is add together all our numbers that we have listed above and divide it by the amount of numbers there are. So when we add these up, we get 9,703.7, and we have a total of 12 numbers, so we just divide it by 12. We get 808.64 once we divide that out. Our median, what we're going to want to do is list our numbers in order from least to greatest and find our middle number, okay? So in this case, when we do that, we have two middle numbers. So we take our two middle numbers, we add them together and divide by 2, and you should get 811.7. Mode is the number that occurs the most. In this situation, there is no number that occurs the most, so we're just going to put none. Every number only occurs one time. Our range is our biggest subtracted from our smallest number. So we'd have 897.4 minus 726.3, making our range 171.1. And our standard deviation, what we're going to need to do is get on our calculators. We need to hit the stat button, hit enter, enter in each one of these numbers, hit stat again, go over to calculation, and hit enter 4 times. Then we're looking for this symbol on our calculator, and our standard deviation for this situation is 53.158. Moving on to the next type of question is we're going to throw outlier in. Remember, outlier is a number that is either much greater or much smaller than our sets of data. So looking at our set of data, we can see that, I'm going to highlight it here, 62 is a number that is much greater than our sets of our other data. So we're going to identify that as 62. Then we need to find our standard deviation, mean, median, mode, and range. So first we're going to do it with. So we're going to just use all our numbers, including the 62, to find mean, median, mode, range, standard deviation. So mean, when you do that, you add them all up, divide by the amount of numbers, you get 37.67. Median, you put them in order from least to greatest. Find the middle number, should be 36. The mode is 36. The range is 40.35. And our standard deviation is 9.89. Okay, remember that is with our 62 included. Now we have to do the same thing without the outliner. So what we're going to do is we're just scribble out that 62, and we're going to do the exact same thing just without the outlier. Okay, so when we do it this time, our mean is 34.63. Our median is 34.5. Our mode is 36. Range 16. Standard deviation is 5.17. So when we compare the set of data, it says describe what happens when we go from with the outlier to without. So what's going to happen is we can see that when we add that outlier in there, all our numbers really increase. So we're going to say our mean, median, range, and standard deviation all increased. Our mode stayed the same. Okay, this is our last set of central tendency questions, and it says the data set below given in wages in dollars of 10 sales associates from Abercrombie & Fitch. On a holiday, each associate earns a 15% bonus to their wages. Then we're going to calculate all our mean, median, mode, range, and standard deviation. And then we need to find out what it's going to look like after we give them that 15% bonus. Okay? So once again, we're going to go through and we're going to calculate our each of these. So our mean, we're going to add them all up, divide them by the amount of numbers there are. That's going to give us 23.94. The median, we're going to find our middle number. That comes out to be 24.49. The mode, there is not a mode. Range, biggest minus smallest, was 17.78. standard deviation using our calculator, we get 5.12. Okay, now to figure out what their wages are going to be with the bonus, we have to multiply each of these by 15%, but we want to change it to a decimal. So we're going to go through and we're going to times each of these by 0.15, and every single one we're timesing by 0.15. So when I times this out, I get $3.59. So that is what they're going to get as a bonus, okay? So then we just add together $23.94 plus $3.59. That gives us $27.53. And then we just do that same thing for every one. 24.49 times 0.15 gives us $3.67. We're going to add that to our original number, 24.49. When we add those, we get 28.17. The mode, there was no mode, so we don't have to worry about it. We're going to times 17.78 times 1.5 or 0.15. We get $2.66. We add that to get 20.44. And our last one, we multiply it, we get 0.76. Add that to 5.12, we get 5.88. Okay, when comparing our results, it says, describe the bonus's effect on the measure of central tendency and dispersion. Okay, so what we can see is all our values increased by 15%. So all increased by 15%. All right, the next question is our normal distribution questions, okay? So there's a formula we're going to use to solve all these types of questions. It's going to be z is equal to the number of interest subtracted from our mean divided by our standard deviation. So going through this question, it says the scores on a standardized test administered by 10,000 students have a mean of 50, I'm going to put the mean symbol over it, and a standard deviation of 10. I'll put our standard deviation. It says what percent, so we're looking for a percent, of students scored below 50. That's going to be our number of interest. So the first thing we want to do is get a bell-shaped curve going here. So we always want to put our mean in the middle. In this problem, the mean is 50. And they want to know how many students scored below 55. So I'm going to just put 55 as, somewhere about right here. Put 55. And it's below, so I want to shade everything to the left on our graph. And I can go ahead and say, V, our number that we're looking for, is going to be less than 55Vx, whatever variable you want to use. So now all we're going to do is plug in our numbers to our formula. So we're going to have Z equal to our V is right here, 55. So 55 subtracted from our mean, which is right here, 50, divided by our standard deviation, which was 10. Plug this into your calculator. You're going to get 0.5. I'm going to put a 0 there. I'm going to circle this. Now we have to get our table out. We're going to use our z-score table. Okay, so if we pull up our z-score table, I'm going to go ahead and put that up real quick. So our z-score table right here, if we look at that, we can see if we find 0.5, we'd be right here at, 0.6915. Now we need to change this to a percent. Okay, so if I go back over here, I'll rewrite that number. So what we found that to be, remember we're looking on the outside. We're looking on the outside of our z-score table. We get 0.6915, okay? We need to change this to a percent. That's what the question's asking for. So we're going to move it over 2 times to the right, and we get our answer to be 69.15%. So looking back at our graph, right over here, our table, or a bell curve, we can see that about 69.15% people score below 55% on that test. And that looks pretty accurate based on what we drew there.
All right, so in part B, this would be similar to the problems you did in 11.3 day 2 notes and homework. So in these problems, you are given a percent and you're going to be asked to figure out what the number of interest is. So that's your V value. And so we'll use the information from part A, where the mean is still 50 and the standard deviation is still 10. So the first thing you want to do is fill out your bell curve. You're going to put your mean in the middle. And then in the problem it says, in order for a student to fall in the top 10%, now that word top is important, we'll get to that in just a second, what score did they need to receive? So you want to estimate where you feel the top 10% is and try to be as accurate as possible, but mainly, 10% is a fairly small space on the entire curve, and make sure you are considering it's the top 10%, so you want to be shading to the right of the mean, which is 50. So if this is representing 10%, we need to calculate what would be that cutoff score that would put you in the top 10%. And so because this is a problem where we shaded to the right and it's saying it's a top 10%, or you can think of it as an above them problem, the very first step you have to do is take 100% and minus the 10%. And when we do that, we get 90%, but you want to change that to a decimal. So you'd be moving your decimal 2 to the left, and that's going to be 0.9. So once you know what the decimal is, you want to find that on the inside of the Z table. And you might not be able to find 0.9 exactly, but you want to get as close to 0.9 as possible. And so if we pull up our Z table, these all range from 0.0 to 0.4. So this would be our negative side. We want to go to our positive side. Let me move that one up. Okay, on this Z-score table, we're looking on the inside of the table. We're looking at what were percents changed to decimals. And so if we're looking for 0.9, the closest thing we find to 0.9 is, there's really two I think would work fine. You have let me switch back to pencil. You have 0.8997 and you have 0.9015. Now either one would work fine. For this example, I'm going to use the 0.8997. And so what you do once you locate the percent as close as possible to 0.9 is you need to convert that to your Z-score. And so how you do that then is you want to go all the way to the left. And then you want to go, hold on, I was on highlighter. So all the way to the left, that's going to be represented with a 1.2. And then you have to go up. And then your second decimal should be an 8. So let me move this over. 1, put this here. Z is equal to 1.28. 1.28. All right, so now that you know Z, keep in mind you're still trying to solve for V. So this is where you use the formula, all right? And that formula is Z is equal to V minus your mean over standard deviation. And we want to plug in the things that we know. So we know Z, we just found it out. Z is 1.28. That's going to be equal to V is what we're trying to find, minus the mean, which is 50, over your standard deviation. You solve these all the same way, this one, and then I think this comes up again in part D. We need to get rid of the 10 on the bottom by multiplying by 10. When you do that, 10 times 1.28 gives you, we'll move this all over here, 12.8 is equal to V minus 50. In order to get rid of the 50, we have to add 50 to both sides. And 12.8 plus 50 is 62.8. And so that's your final answer. So a score of 62.8 or higher on this test that they're speaking of is what would allow you to fall into the top 10%. All right, now let me make these Z-score tables smaller so we have room to see what we're doing. Part C is like the one it's more like part A, the one that Mr. Robertson did. And so in part C, it's asking for what percent of students scored above 80 on the test. And so we're trying to find a percent. We're given the number of interest. So our number of interest, V, is 80. We still want to put the mean on our bell curve. Let me move this up. So the mean on our bell curve is still a 50. We want to place 80 on the curve. Let's just put it here. And we want to know what percent of students scored above an 80. So think about this. We are looking for this percent. We want an above an 80. So you have to keep in mind that at the very end of this problem, you're going to want to subtract from 100. This is like a day one, 11.3 day one problem. So we do the subtracting from 100 last. And so the first thing we want to do then is we want to plug these numbers into our formula and figure out what Z is. So Z is equal to number of interest minus mean over standard deviation. Z is equal to the number of interest in this problem is 80. The mean is still 50. Standard deviation is still 10. 80 minus 50 is 30 over 10, which gives you 3. So we have a z-score of 3. So now this is where we have to take our z-score table, and we need to locate 3 on the outskirts of the table. And so I'm going to pull up, here's the positive side of it again. And let me erase the stuff from the previous problem. And so what we need to do is on the outsides, we need to find 3. And so if you look, it's located right here. And it's just 3. We don't have anything after it, so it's 3.0 and technically is 0 again. So that means the percent that corresponds to it is 0.9987. So we need 0.9987. Now that's a percent written as a decimal. Let's go get rid of this out of the way for now. And so, oops, I wrote it on the wrong. I think it ended up writing on the wrong paper. All right, so let me make this smaller and write it next to our actual problem here. So 3, a z-score of 3 is represented by a decimal of 0.9987, but you want to turn that decimal into a percent by moving your decimal place 2 to the right, and so that's equal to 99.87%. But be careful, because this was an above then problem. This was shaded to the, as I'm shading it right now, this was shaded to the right, so the last step is you need to take 100 minus 99.87, and that's going to equal 0.13%. So it's a very, very, very small percent of people score above 80 on this test. Your last problem, part D, is similar to part B. And this one says, in order for a student to fall in the bottom 5%, what score did they need to receive? So we are given a percent. Keep in mind this is a bottom 5%, so it's like a less than problem, it's a shade to the left problem, and we need to figure out what score. So that means what is V? What is your number of interest? And so on your bell curve, what you have to do is place your mean in the middle still. Estimate where you feel the bottom 5% is. Just do the best you can. Make sure, most importantly, that it's to the left of the 50, so call this 5%. We need to figure out what is that number of interest. What is the cutoff score that says, hey, if you're this score or below, you're in the bottom 5%. And so the first thing you have to do, because it's just a bottom number, it's a less than problem, you do not have to subtract from 100. So you need to take your 5% and you need to change it to a decimal. So if your decimal point is located right here, we move it 2 to the left and we have 0.05. We need to find that on the Z table, and it's going to be on the inside because it's a percent written as a decimal. And so I'm going to make a note of that. Let me see how I wrote it in the above problem. Inside of Z table is what we need to locate. Find on inside of Z table, just like we did in part B. So this one's pretty small. It's going to be on the negative side. So if we zoom in here, keep in mind it's not 0.5, it's 0.05 or the closest thing to it. So 0.05, I'm looking like we're in this general area right here, but you want to get as close as you can. And really I see two possibilities. So I would go with either this one, 0.0505, or this one, 0.0495. For this problem, I'm going to go with 0.0505. So let me erase the other ones, and let me erase the big circle. And so what you do is, since that's the one we're going to use, 0.0505, that needs to get converted to a z-score. So you go over to the left, negative 1.6, and go up. Your second decimal will be a 4. So let me write that, negative 1.64. Z is equal to negative 1.64. And now that we have our Z number, we can plug these into our formula. The original formula is Z is equal to number of interest minus mean over standard deviation. Plug the things in that we know. Z is negative 1.64. We're trying to figure out our score, so that's our number of interest, minus 50 over 10. Multiply both sides by 10. This is going to take us to 10 times negative 1.64 is negative 16.4 is equal to V minus 50. Add your 50 to both sides. And when you do that, you get that V is equal to 33.6. So that's a cutoff score. That means that if you score a 33.6 or lower on this test, you are in the bottom 5%. So make sure you study these problems and look at the difference between the ones that are day 1, where your final answer is a percent, and the ones that are day 2, where you're finding the number of interest, the V. And so that takes us then to our last section, 11.4 problems, the types of sampling. You get these off to the side. First type is going to say, it's going to give you a situation and you have to decide on the type of sampling that's occurring. So this one says a newspaper is sponsoring a poll and wants to find out the preferences of farmers across the state regarding the governor's election. Keep in mind, couple keywords here. They're looking to figure out preferences across the state. But the newspaper surveys farmers in the local area. So identify the type of samples. Something you could think about is if you wanted to sample the whole school, but instead you just decide to sample the kids in your first hour. You're doing what is easiest, what's the most convenient. So this would be an example of convenience. And then you'd want to decide if you feel that this is a biased or unbiased way of sampling. And for this example, I would say that this is a biased sample because we are only surveying farmers that are in the local area. We did not survey farmers in other areas of the state. So we'd say biased. Only local farmers were surveyed. All right, so on to our next page then. In these problems, in the first type, it is giving you a situation or an example of a survey. In number 8, it's asking you to find the margin of error. So it says in a survey of 1,600 U.S. adults, 61% said that they have purchased a product online. What is the margin of error for the survey? Round your answer to the nearest 0.1%. So to calculate margin of error, what you want to do is use the formula of 1 over the square root of your sample size. And so you take 1,600, that was our sample size, and you can plug that right into your calculator just like you see it. And when you do that, what you get out is, it's always plus or minus because that's what allows you to get to your interval, but you get out 0.025. But you're not done because it needs to be a percent. So don't forget, move your decimal 2 to the right, and your final answer is plus or minus 2.5%. That is your margin of error. So for number 9, you're going to use that piece of information. It says, give an interval that is likely to contain the exact percent of all U.S. adults who have purchased a product online. And so what that means is if you could actually survey every single adult in the U.S., we want to figure out what interval would the exact answer fall in. And how you calculate that is you take what your survey found, which was 61% out of the 1,600 adults, and you add your margin of error. And when you do that, you get 63.5%. And then you take your answer, again, your 61% from your survey, and you subtract your margin of error, and that's going to give you 58.5%. And so how you want to write this, though, you want to write it as an interval. So you want to start with the lower end, 58.5% through 63.5%. That is the interval that would contain the exact percent of people that have made a purchase online if you could survey every adult in the U.S., which would be impossible, but that's your answer. The last type of problem that you're going to see on your test is it's going to be one that looks like this, where it's giving you the situation here. It says a survey claims that 15% of high school students prefer having gym class during the last period of the day. The survey reports a margin of error of plus or minus 5%. So they're giving you the margin of error. They're asking you to figure out how many students did you sample. So it's working backwards from a problem that was like number 8. And so if in number 8 you do 1... In number 8, we did 1 over the square root of our sample size. And that gave us our margin of error written as a decimal, so that's important. We need to work backwards. And so we want to take our margin of error, which is plus or minus 5%, and we need to turn it into a decimal. And so we would say that if the decimal point is right here, we need to move it 2 over, and so we'd have 0.05 as our decimal. And so what you want to do is you can kind of take a shortcut on this type of a problem. You can take, since we, in order to get margin of error, did square root, you can do the opposite of a square root, which is squaring, and we can put that on the bottom of our fraction. And so what you want to do is you get rid of the square root, you take our decimal of 0.05, and you're going to square that because that's the opposite of square root. And this will not now give us margin of error, but this will now give us our sample size. And so let me erase margin of error. So once we erase that, what you can do is you're going to get out from this problem, you're going to get out your sample size. And so all you have to do is plug it into your calculator just as you see it. 1 divided by 0.05. Make sure you square that. And when you do that, you get out that your sample size was 400 people. Then you're all set.